Hey, D. Dykstra here again with another great math video. This time we're talking about solving rational inequalities. Okay, so we just looked at one where we were solving polynomials, and now inequalities. Now we're looking at rational inequalities. So here we go. Let's take a look. What are some of the steps we need in order to solve these rational inequalities? So one thing we're going to want to do is we've got to set the numerator equal to 0. When we set the numerator equal to 0, we're going to find out where the graph crosses the x-axis. Okay, so where is that? We'll find those x-intercepts, which will be key because either the graph is going down, crossing, and that's where it's going to be negative, or from the 0 it'll be positive. And so we want those x-intercepts. The denominator will tell us where the function is undefined, because in a rational graph here, we have some asymptotes. So we want to figure out, well, the graph is going to be on one side of the asymptote or the other side. Okay, so these are vertical asymptotes we're looking for. Where is f of x undefined? Where are those vertical asymptotes? Then what we can do is we can factor the top if need be, set those factors, all those x values we'll need for the numerator and the denominator. Again, we're going to create an interval table and with some test values, and then we're going to draw a number line to represent the table and the intervals that satisfy the inequality. Alright, so let's look at number 1. Example, here we go. So we have 3x plus 3 divided by 2x plus 4. Alright, so and we want to know where is this function greater than 0. So if we look at the numerator, 3x plus 3 equals 0. We get that if we subtract 3, we divide by 3, we get x will be, it'll make it at negative 1. All right. Now, the other one, and so we'll put a little table together that shows our negative 1 value. If we look at the denominator, so this is where it will be undefined. So if we subtract 4, and then divide by 2, we'll get x is negative 2. So negative 2 is where it's undefined. That's what this U stands for. We're undefined here, so we're not going to have anything there. We're going to be on one side or the other. Then at negative 1, that's where we have a 0, right? So we know it's 0. So what we want to do, again, is we want to go to the different sides. So I'm going to choose some values here now, and we'll see what's the function doing. Is it negative? Is it positive? What do we want? And what we're looking for is when is it positive. Okay, so let's try from the right side. Well, negative 1 is a 0, but I'm going to try the number 0. If I put a 0 here for this x, that's going to be a positive number. If I put a 0 here for this x, that's going to leave positive. Positive divided by a positive is a positive. All right. Now, inside here, well, there's a very small window of opportunity here. Negative 1 to negative 2. So I'm going to use the value negative 3 halves. And if you plug negative 3 halves in here, that'll be 9 halves, 12 halves, that's going to be a negative. And then 3 halves is 6 halves, that's negative 3, so that's a positive. So negative divided by a positive is going to be a negative value. So that's a negative. Now over here, we can try the value of negative 3. Well, if I put a big negative 3 in here, that's going to make that whole thing negative up top. And if I put a negative here, it's going to be negative 6. Negative 6 plus 4 is a negative. And so I will end up with a positive value. So I get a positive, negative, and positive. And what we'll notice is that on this graph, it's a graph that comes up through, has a vertical asymptote at negative 2, and up high on the graph, there's a swoop that happens up here, and then it kind of comes up. And once it crosses this 0 or negative 1, then it becomes a positive value. So what we're going to do is we will say that from negative 1 or negative 2 on over, right, we are going to be this way and positive. And then at 1, we're going to be positive, so we'll go that direction. All right? So we're not going to include 2 because at 2 it's undefined. So any number greater than 2, we should end up getting a value that is a positive result because that's what we're looking for, positive. All right, let's look at example number 2. I didn't write that down, but this is example number 2. This was example number 1. All right, example number 2 says, a little more complicated now. Got a little more stuff here. It says, well, all right, check it out. You've got x plus 1 over x plus 3. Where is that greater or equal to 2? Again, following one of the rules we had before, we got to get everything over. We want to know positives and negatives. So I move the 2 over that through subtraction. And now we get x plus 1 divided by x plus 3 minus 2. Well, that doesn't work too well, so we need a common denominator. Here we have x plus 3. We might as well make another x plus 3. Multiply top and bottom, right? And so now we can combine because we have the same denominator. So there's our same denominator. We get x plus 1 minus 2 times x plus 3. After we distribute, we can distribute this negative 2 now. There and there. We get x plus 1 minus 2x, right? Minus 6. Negative 2 times positive 3 is minus 6. We combine like terms. We get negative x minus 5 all over x plus 3. Where is that greater than 0? So again, just to recap what we did here, if we ever have a number, we need to move it over, find a common denominator, and then simplify all the terms so we get back down to a basic numerator and denominator. All right, so we take the 2, the numerator, which was negative x minus 5, and the denominator, x plus 3. We're going to set those equal to 0. We need to find the 0 and the undefined. Well, negative x minus 5 was the numerator. Set that equal to 0. Add 5, divide by negative 1, we get x is negative 5, so I put that here. That's the numerator, so that's the 0, where it crosses the x-axis, right? X plus 3 is the denominator, so at x is negative 3, that's where it's undefined, so I put a little u to remind myself there. And now what I need to do is once again choose values in between. Well, over here, less than negative 3 is 0. Well, if I go back to our function, let's go back to our function, negative x minus 5. I guess I should write that down. Negative x minus 5 all over x plus 3. We want to know where is that greater or equal to 0. Okay, so here we go. If I plug 0 into this function, we get 0 minus 5. That's a negative number. 0 plus 3, that's a positive number. So I get a positive here. Okay, and then I want to know what is in between 5 and 3, so I'm going to choose negative, oops, I don't want to put that there, I want to put that here, and negative 4, excuse me, negative 4, and so at negative 4, 0 was a negative number, excuse me everybody, sorry, 0 was a negative number, negative. I know you're thinking, wait, no, it's not. It's a positive. No, well, I just made a mistake. Okay. So then, negative 4. Well, negative and a negative, that's going to be a negative here. Negative 4 is greater than 3, so that's going to be a negative 1. So I get a negative divided by a negative. Makes this a positive. And now we try negative 6. And negative 6, well, that still says, negative 6 now up here changes that to a positive, but we have a minus, but this is a minus, so that's also going to be a negative. And so we find that the interval on which we are set to go, where we are looking greater than 0, is in between. Now, what we can do in this case, however, is at negative 5, right, we can have it. Negative 5 is the numerator. So we can have something equal 0, so I can go ahead and fill this circle in, right? Fill that in. Now that's okay. But now when we come over here, I'm going to move over here. Circle there. Ask yourself, can I fill in that circle? Why or why not? Well, the answer is that no, you cannot. Because remember, once again, that negative 3 is the denominator, and that's where it's undefined. So now we have our table and our subsequent number line showing the interval progress, where it satisfies the equation negative x minus 5 over x plus 3. Where is that greater or equal to 0? All right, got the way for you there. Take a look, pause it, need some help. Okay, awesome. Well, again, this has been another great math lesson for you. D Dykstra. Hope you have a great day. Peace. Keep it mathy. See ya.